Hi, grade 9s. We are looking at Unit 5, Day 4, and this is going to be similar to the Day 3 work, but we're going to be finding the equation of a line in terms of a word problem. I will post this on as a link in the unit outline as well, so you can see the handout here. So this says, at home, Mei Ling carries out a water freezing experiment. Unfortunately, she loses her data sheet on the way to school. She does not recall much of her data, but she remembers that at 4 minutes, the temperature of the water was 19 degrees, and at 8 minutes, the temperature of the water was 16 degrees. So she wants to find out what the temperature of the water was 10 minutes into the experiment. Mei Ling knows that the relationship between freezing time and temperature is linear. So the first question says, state the independent variable and the dependent variable. So my two variables here are time and temperature. So we have to decide which one of those depends on the other one. I always kind of like to think of it as which one is affecting the other one, or which one is independent and not reliant on what's happening with the other variable. So does time happen independently from temperature? Does temperature happen independently from time? So here, I think we can see that the temperature of the water in terms of the temperature here, in terms of how many minutes after you put it in a freezer, that's going to be the dependent variable. The temperature is going to change based on how long it's been in the freezer. The time on your clock doesn't change based on the temperature of water in your freezer. That doesn't make sense. So the temperature is changing based on how much time has happened. So time is my independent variable, and that's in minutes. And the temperature in degrees C is my dependent variable. So the first method for looking at how to find the equation of this line, of this relationship, is by looking at a graph. So it says, plot the points 4:19 and 8:16 on a graph. So if I was going to graph this is a good chance to review some of the important skills with graphing that we did in the last unit. So I need to label my axes. I'm going to use a ruler, and I need to have a title. I need to talk about my scale. So my independent variable is going to go along the horizontal or the x, and that's the time in minutes. So I need to go up to 8 for sure, but I think I'm going to want to bring this forward a fair bit. So I think I'm going to count by 2s across the horizontal axis here. So notice that I've labeled, a little bit messy, but I've labeled the axis with time. Not just that, but I have the units for the time. I'm measuring in minutes, and I've labeled in my scale. Now on the other axis, on the vertical axis, I'm going to label that temp in degrees Celsius. So that's my vertical scale is in degrees Celsius for temperature, and I see that the temperature is decreasing. This is an experiment to freeze water, so I don't think that it's going to get any higher than that original, much higher anyway, than that original 19 degrees. So I'm labeling my scale, counting also by tens. Now it says to plot the points 4:19 and 8:16. So to plot those points, I'm going over to 4 and then up to 19, which I'll have to estimate halfway between the 18 and the 20. And then the point 8 and 16, going over to the 8 and up to the 16, and plot a point there. I'm going to connect those points. Again, really important to use a ruler. If you don't have graph paper, you're going to want to very carefully do the trick of turning 2 pieces of line paper, one sideways under the other one, so that you can see the lines and very carefully draw that in, because it will be important to be able to graph these accurately. So I'm drawing a line through there. Now, one thing that I'm missing is a title here. So I'm going to write water freezing time versus temperature. Your title can be kind of whatever you want, as long as it's explaining and relevant to what's happening in your graph. So if I wanted to calculate the slope of this line, remember we do the slope of a line from a graph by using that rate triangle. So I'm going to draw in my rate triangle and look at my rise. Now the first point here was at 19 and the second point is at 16. So it's actually decreasing. It's got a negative rise. 16 minus 19 is -3. It's going down 3. And the run, it's going across in the positive direction. So the run is 8 minus 4 because it ended at 8 and started at 4. So the slope of this line slope is rise over run, and that would be -3 over 4. So the temperature is decreasing 3 degrees every 4 minutes. And that's what part C asks us. It says, what's the meaning of the slope in this situation? So the temp decreases 3 degrees Celsius in 4 minutes, or 3/4 of a degree Celsius per minute. So it's 3 degrees in 4 minutes, or it's 3/4 of a degree in each minute. The next thing wants us to use the graph to find the y-intercept. So that's just kind of patterning back. It's pretty obvious, I think, from here, and if you graph accurately, hopefully you'll get this too, that my y-intercept is 22. I can kind of pattern this back as well. So going from the 8 to the 4, I went 4 over, or 2 squares, and 3 up, and then going 2 squares over and 3 up, which is 1.5 squares. That'll get me to the 22. So a couple of different ways to look at that. So the B is 22 degrees Celsius. That's the starting value of the temperature of the water. So if we have the slope and the y-intercept, you guys know that we can find the equation of the line. So it's y equals -3 over 4 x plus 22. We should state what we're dealing with here. So x is the time in minutes. Make sure that whenever you have a word problem, you're saying what your variables mean. So x is the time in minutes and y is the temperature in degrees Celsius. So part F says, what's the meaning of the y-intercept in the context of this situation? So this means that the y-intercept is the starting value, and the y values, remember, are our temperature, so the y-intercept is the starting temperature of the water. So this is the starting temperature of the water. Okay, so the last thing is list the steps to finding the equation of the line using the graphing method. So the things that we did here, the first was to choose or identify dependent and independent variables. The next thing, because we need to know which one is the x-axis and which one is the y-axis. The next thing was to graph. And the following steps are just what we did before when it wasn't word problems. So then we find slope. Then we find the y-intercept and write the equation. And these 3 steps, I think you guys will see, were very familiar if you watched the video from day 3. Now, those are always the steps in solving or finding the equation of a line. You need the slope, you need the y-intercept, then you write the equation. If you don't have a graph and you want to use a graphing method, then you have to do those first 2 steps as well to be able to create that graph.